looking at exercise 9D. What we still have to do after today is to sketch exponential and logarithmic functions. We have done them with log to the base 2 of x, but we'll just be doing log to the base e of x next lesson and sketching e to the x. Remember, e is just the number, Euler's number, which lies between 2 and 3. So it looks the same as the others. It's almost identical. All right, so we'll be spending our last lesson on that, sketching e to the x and ln x and transformations, moving them up, moving them down, sideways. I just want to get all this other stuff done first. So nothing really new here today. We're just combining the fact that you know how to factorize something like e to the power of 2x minus 1 and find a gradient of tangent, equation of tangent, and things like that. We did do 1 or 2 questions like that 2 lessons ago, but we were only doing it with e to the power of x. So now we're combining our stuff on linear function with differentiating e to the power of function of x as well. So just looking at exercise 9D. So let's look at this first question, question 4. Now, sometimes they give you the coordinate of on the curve. So point A is on that curve, and they're just giving you the x coordinate. So they're just asking for the y coordinate first. Do you know what you would do? So this is my curve, y equals 2 to the power of 2x minus 1. It's just saying find the y coordinate of point A on that curve, and you know that x is a half. So what do I do? No. Part A. No differentiating. I know that x is a half. When you want a point on the curve, you just substitute into the curve. So substitute x equals a half into y equals e to the 2x minus 1. I'm not asking for the tangent, the gradient of the tangent yet. I'm doing part A. Like I said, sometimes they give you the coordinate, the x and the y value. A lot of times they only just give you the x value. So look, I'm going to do e to the power of 2x minus 1 would look something like this. It's an exponential curve. So we've got the point a half something. They're just asking for the y value on that curve. That's all they're doing. So they've said, this is your function. It looks something like that. Actually, when x is 0, so it would look like that. I'm not going to put y-intercept yet. We haven't sketched those types of functions yet, okay? So when x is a half, what's the y value? So what do we get? Y is e to the 2 times what? Anyone? A half minus 1. What's 2 times a half? So that's 1 minus 1. 1 minus 1, which is e to the 0, which is, what's it? Anything to the power of 0. 1. So the coordinates of point A is a half. What's the other one? Now, actually, while we're here, I know we haven't sketched these curves, but tell me when x is 0, what is y on this curve? Let's just do it anyway. So I'm going to find the y-intercept on this curve while I'm here. When x is 0, y is what? E to the 0 minus 1, which is e to the negative 1. Can you write that as a fraction for me? 1 over e. So that's actually my y-intercept, 1 on e. There. Now 1 on e is about a third. So my other point should be a bit higher. Who's got on e? So it's got coordinate 0, 1 on e. This is when x is a half, y is 1. So this is what I've got here so far. Now, so we've just done part A. I've worked out the y-intercept because I did a bit of a sketch. Now for part B, it says find the derivative of y equals e to the power of 2x minus 1 and show that the gradient of the tangent at A is 2. And then in part C, we're going to find the equation of the tangent at A. This is the point A, all right? And we're going to find the equation in part C and show that it passes through 0, through the origin. So what do I do? Y is e to the 2x minus 1. Gradient of tangent. What do? Differentiate. You always differentiate to find the gradient. So how do you do that? How do you differentiate that? You write it out. It's the same thing times, but that's a function up there. So differentiate the 2x minus 1. So the derivative is 2e to the 2x minus 1. Now what do I do? Now what do I do? They want the gradient of the tangent at A. What do I do now? At A, what do I substitute in? What do I know at A? So girls, that's the gradient function, and then when I substitute in different values of x into the gradient function, so this is my gradient function. Always the derivative is your gradient function. Look, the gradient changes all the time on the curve, depending on the value of x that you substitute in. So now I substitute x is a half into that to give me the gradient when x is a half. Because it wants the tangent at A. A has coordinates 1, half, 1. You always substitute the x value in. So at A, where x is a half, dy dx is 2 times e to the 2 times a half minus 1. You okay, girls? So you differentiate, you get the gradient function. Depending on the value of x that you substitute, you can find the gradient of the tangent to the curve at any point. Now what do we get? What's that? 2e to the a half, 2 times a half is 1 minus 1. 2e to the 0. What's e to the 0? 2 times 1, which is 2. So therefore the gradient of the tangent at a half 1 is 2. So therefore the gradient of the tangent at A, which has coordinates a half 1, is 2. And now it says find the equation of the tangent and prove that it passes through the origin. So find the equation of the tangent and prove that it passes through the origin. I'm moving this up. So I want the equation of the tangent. Equation of tangent at A. How do you do that? What do you need to find the equation of a line? 2 things. What are they? The point and the gradient. Whenever you want the equation of a line or a tangent, point gradient formula. What's your point? It's A, which is a half 1, and your tangent gradient of is 2. So you just do y minus y1 equals m bracket x minus x1. Now I'm going to draw the graph back down here because I don't want to keep looking up there. And that's your y-intercept. So y minus 1 equals 2 bracket x minus a half. Y minus 1 equals 2x minus 1. Y equals 2x. Yeah, because it's minus 1 plus 1, you get y equals 2x. So that is the equation of the tangent. Now, if you sketch y equals 2x, do me a little, what happens when x is 0, girls? So, now, look, when x is, I'm trying to draw the tangent, but I haven't drawn it in yet. So this is my equation of tangent. You know when you've got an equation like that in y equals mx plus b form? There's no b. The equation of the tangent is y equals 2x. So the y-intercept is 0. So now if I do a little table of values, for example, when x is 0, what's y? Yeah, y equals 2 times 0, which is 0. Yes, it is. So y equals 2x is just y equals x, but steeper. So we know that it passes through half 0, and we know that it passes through 0, 0 now. Because I just looked at the equation of the line y equals 2x, and when x is 0, I saw that y is 0, therefore the tangent passes through the origin. Does that make sense or not? Do you know why it passes through? Because when you put when x is 0 into this equation, you get y is 0. So therefore the curve passes through the origin 0, 0, because when x is 0, y is 0. I want you to start, spend a few minutes. Be careful, this is e to the power of x is on its own, and then there's a big take away 1. So that minus 1 is not part of the power. So first, we've got this curve y equals e to the power of x minus 1. Now, if I just did a very quick sketch of that curve, it looks like 2 to the power of x or 3 to the power of x. All those exponential curves look like this. That's y equals e to the power of x. It looks like this. Because it's just like 2 to the power of x or 3 to the power of x. That's what it looks like. We aren't going to spend a lesson sketching it. But what would this curve, if that's y equals e to the power of x, what does e to the power of x take away 1 look like? Shifted down 1 unit. Now, tell me with this curve, when x is 0, what's y? When x is 0, e to the 0 is 1. When x is 1, e to the power of 1 is 2.7 e. All right, there's some coordinates on that curve. But that's not the curve that we're looking at. We're looking at y equals e to the x minus 1. So just the whole curve has been shifted down 1 unit. So all I need to do, where it was 0, where it was 1, it's now 0. What's the asymptote for the original curve? What do you think? Yeah, that's the asymptote. The x-axis is the asymptote. What do you think the new asymptote's going to be? So the whole thing's shifted down 1. The new asymptote will be y equals -1. So this is what the curve's going to look like. So this is the curve y, the red one is y equals e to the x minus 1. It's just the e to the x curve shifted down 1 unit. I'm just going to draw it like that so you get an idea. It's not the best drawing either. It should be more like that. Okay? Now, when you sketch a curve, you should be really showing more than 1 point on the curve. I'm just going to put this other one. When e is 1, what would this point be? When x is 1. What do you think this next point is? E to the 1 minus 1 is just e minus 1. Don't worry about it yet. We're going to be doing more of that next lesson. All right, so that's just my curve. All right. Actually, that is a good idea. They just asked us for that. So start with question A, but set it out properly. This is what we've got. Y equals e to the power of x minus 1. They're asking for the y coordinate of the point where x is 1. So when x is 1, what does y equal? That's what I just did. What you get? E to the, come on, 1 minus 1, which is just e minus 1. So the value would be about 1.7-ish. Remember, e is about, so the coordinates of this point, sorry, I've drawn it really, really badly. All right, I'll do it down here. I'll just put the new one on. So the coordinates are, this is what I've got. This is the point 1, e minus 1. That's your point. This is my curve. It looks like this. This is my asymptote at -1. So that is what my curve looks like. Have you got part A? All right, so that's what my curve looks like. It actually passes through the origin as well because we said that it's shifted down 1 unit. Or you could look at the equation y equals e to the power of x minus 1. And when x is 0, what do you get for your, so what do you get when x is 0? E to the 0 is what? 1 minus 1 is 0. So for that curve, when x is 0, y is e to the 0 minus 1, which is 1 minus 1, which is 0. That's why you've got the curve passing through 0, 0. Okay? So I need to move up. Differentiate the curve and find the value of the derivative when x is 1. What's that giving you? So what do you get? Differentiate. dy dx is, yep, very good. Now, they want the value of dy dx when x is 1. So when x is 1, dy dx is e to the 1, which is e. So what does that represent? This is the gradient function, and this is the gradient when x is 1 of the curve. Okay? Now they want you to find the equation of the tangent at P. So do you have the gradient? And you have the point. What's your gradient at point P? Yep, gradient's E, and point P is 1, comma, E minus 1. That's point P. Okay, point gradient formula. Y minus Y1 equals M bracket X minus X1. Off you go. Y1 is, be very, very careful. So Y minus, Y1 is E minus 1, so you have to put it in brackets. Did we do that? No. Good. Equals M is E bracket X minus 1. You better open up your bracket first. I would probably open it, or you could take it over to the other side. Who opened? So Y minus E, what, plus 1, very good, equals E to the X minus E, fantastic. And let's just put it into Y equals mx plus b form and take everything over to the right. This is E times X, so it's like 2.718x, all right? Minus E, you should recognize that the minus E's are going to cancel, you know, but minus E plus E minus 1, okay? Which is Y equals E times X, what? Very good. So that is the equation of the tangent. So that is my equation of tangent at P. And now the next question says, for what values of X is the curve stationary, increasing or decreasing? For what values of X is the curve stationary, increasing or decreasing? I probably don't even have to differentiate. Is this graph ever flat? Because it has to be perfectly flat to be stationary. So it never is. So what we're going to do, I'm going to try and solve it, and you'll see that it's impossible to solve. So if you look at this, isn't this curve always, doesn't it always have a positive gradient? So let's just answer it by just looking at the curve first. So the curve is never stationary, always has a positive gradient, yes? Always has a positive gradient. Now, positive gradient, remember gradient is always the derivative. So the curve always has a positive gradient. We can see that. The gradient does never equal 0. So the gradient is never equal to 0 at all. So therefore, we think that the curve is never stationary. Now, how can I prove that? I'd have to be able to show that the derivative could never equal 0. Okay, the derivative of the curve can never equal 0. So let me try. So dy dx is the derivative of my curve, and that's e to the x. Now, if I sketch e to the x, it looks like this. That's e to the x. Now that approaches 0 but never equals 0. Now you would say that e to the x never equals 0, therefore dy dx cannot equal 0. It's because, so as we progress, whenever you're trying to solve something like e to the x is 0, and you will be asked to solve it, the thing is you need to write that it's got no solution. You cannot solve it, because if I sketch y equals e to the x, it's asking me, does that curve ever reach y equals 0 or the x-axis? It doesn't, because the x-axis is an asymptote. So no matter what value of x I substituted in here, I will never ever get 0. I'll get very close to 0, but I'll never get 0, because it's an asymptote down here. For what values of x is the curve increasing? So curve is increasing means that it's got a positive gradient. Doesn't it always have a positive gradient? So therefore, but the curve always has a positive gradient. So therefore, what do you want to say? But the curve always has a positive gradient. So you want to say it's increasing. In other words, dy dx is greater than 0. That's what increasing means, that the gradient is positive for all real x. That's it. It's always increasing. And when is the curve decreasing? Curve is never decreasing. All right? Because why? Because dy dx, the gradient's always greater than 0 for all real x. It's asking, when does this curve have a negative gradient? It never has a negative gradient. All right? It never has a negative gradient. So it's never decreasing. So you want to relate increasing with positive gradient, decreasing, curve goes down with negative gradient. Curve increases when the gradient's positive. Curve is stationary when it's not going up or down, and the gradient's 0. So this curve is only ever increasing. And you could have just looked at it by just looking at that positive gradient all the time. Okay? I'm going to do one more. About gradient and equation of normal, finding the x and the y-intercept of the normal and finding the area of the triangle. So the normal is going to be a straight line, right? So let's just do some values. So what about when x is -2, -1, 0, 1 and 2? That'll do. Now y equals e to the x goes this way. Which way do you think e to the negative x goes? Like, it's like the x values are being swapped around. When it's negative, it's now positive. When it goes that way. All right, let's just do, what's e to the -2 mean? Oops. So normally it goes this way. So let's do e to the -2. No, e to the -2. So when x is -2, I'm so sorry, girls, I keep saying the wrong thing. So I'm sketching y equals e to the -x. So when x is -2, don't you get e to the -2, which is e squared? When x is -1, e to the -1 is e to the +1, which is e. Now, when x is 0, e to the -0 is just e to the 0, which is 1. So it looks like this. When x is -1, it's like about 3, and when it's -2, it's about 9. It's going this way, like you said. Okay, that's what the curve looks like. When x is 1, it's e to the -1, which is 1 on e. And when x is 2, it's e to the -2, which is 1 on e squared. That's getting smaller. That's about a third. That's about a ninth. Small, small, small. Right, that's the curve. Okay, off you go. Can you please calculate the gradient of the tangent at that point? And then write down the gradient of the normal and the equation of the normal. So what are you going to do first? Y equals e to the -x. What do you want to do first? Yep. Is e to the -x times -1, which is -e to the -x. When x is -1, you've got -e to the -1, which is -e to the +1, which is -e. Okay. In other words, the gradient's about -3. So it's steep negative. So I'm going to sketch it on this graph. When x is -1, the gradient is about -3, so it's a steep negative. By the way, while we're here, oh no, just leave it because I don't know the equation of it yet, but it's going to be like this. It might pass through 0, I'm not sure. So we better work out its equation before I decide to draw it. Oh yeah, that's the equation, that's the tangent. So that's the gradient of the tangent, be careful, sorry, is -e. Good. Part B. What are they asking you? Yep. So therefore, the gradient of the normal, what do you do with that? The negative reciprocal. So it's a negative, you now make it a positive, because that's really -e on 1. So what are you going to do? Flip it. It's just 1 on e, the gradient of the normal. And now the equation of the normal. So you're going to use your gradient is 1 on e. What's your point? -1, e. Just watch all those negatives and those e's. So you want the equation of the normal. Equation of the normal. You good? Y minus y1 equals m bracket x minus x1. So please be careful. Please don't just throw numbers all over the page. You need to write gradient of tangent is -e, gradient of normal is 1 on e, and equation of normal, explain what you're doing on e. So y minus e equals 1 on e bracket x minus e. Tell you what, so just expand. Y minus e equals 1 on ex. Liquid paper. You know, here, if you're tired, label the points. X1, Y1. Y minus Y1 equals M bracket X minus negative 1, which is X plus 1. So plus 1 on E. Look, if you want to put it into Y equals MX plus B form, just keep that fraction there. But what else could I have done instead? I could have, yeah. So this is what that looks like if I decide to bring the E over. But the other thing I could have done from this step is to do the following. Y minus E equals 1 over E bracket X plus 1. That E is on the denominator. So if you want to put it in general form, you would multiply by E. See, that's really, you could say that the E is on the denominator. Opposite of divide by E is to times the other side by E. So if you were to put it into general form, you would get this, but that's not in general form until you do what? So if I want to put it in general form, I would do this. The X has to stay positive. So I've got to take everything over to the right. So X minus EY plus 1 plus E squared equals 0. That is general form, where it's AX plus BY plus C equals 0, where A is positive. All good? So that's in general form down here. That's in Y equals MX plus B form. I like Y equals MX plus B form because I can see the gradient is about 1/3 and the y-intercept is about 2.7 plus roughly 1/3. It's about 3-ish. All right? So, but we're going to work it out anyway. So that is the equation of the normal. Either way is fine. If they say general form, it has to be in this form. Now, can you find the X and the Y intercepts? So for X intercept, what do? Put. How do you find X-intercept? That's right, sub Y equals 0. Now look, you might decide you like this form to do that. It doesn't matter. So see how the general form's really good for X and Y-intercept? I don't mind which one you want to do it in. Let's do it in the hard one, because you'd know what to do with this one. All right? We'll do it both ways. If I put Y is 0 in this one, I've got 0 equals 1 over EX plus 1 on E plus E. How do you want to solve that? You could either take everything over, but there's a quick way to get rid of the E's on the denominator. Multiply both sides by E. You okay with that? Now, or I could have used this equation over here, and if I put Y is 0 here, I would have got X minus 0 plus 1 plus E squared is 0. So using the general form instead, that is so much easier, isn't it? Negative 1 minus E squared. Let's see if we get that over here. So if I use the general form to do my Y-intercept, I would have just done that, right? If I use my Y equals MX plus B form to work out my, X-intercept, I would put Y is 0 there. Look, if I were you, would multiply everything by E, but you don't have to. Who would have taken these over? Yeah? Or would you have multiplied everything by E? No one's talking. Multiply everything by E? Yeah, it's the best thing to do. So E times 0 is 0. E times 1 on E, you just lose the E. E times that will be E over E is 1. And E times that is E squared. All right. So therefore, X is, take them over, negative 1 minus E squared. That is your X-intercept. Now, for your Y-intercept, you want to put X is 0. Method of doing that, if you've got 0 equals 1 over EX plus 1 on E plus E, other people may have decided to take these two over and get negative 1 on E minus E equals 1 over EX. But then you still need to multiply. From there, that's negative 1 on E minus E equals X over E. You okay with that? Then you have to multiply by E. So you still got to multiply by E. So you need to multiply the other side by E. It really is much better if you know that if you've got denominators, if you're solving an equation and there are denominators, multiply both sides of the equation by the lowest common denominator of the denominators, lowest common multiple of the denominators. So that's multiplying both sides by e. There's one term on the left, but there's 3 terms on the right. You have to multiply each one by e. It's not multiplying the right-hand side 3 times by e. It's just multiplying this by e and this whole side by e. So they're balanced. You multiply the left and the right both by e, and it'll still be balanced. Okay? Or you could have done it this way, which is even worse again. All right? So 3 ways to do it. Now, for y-intercept, put x is 0. See, y-intercept is really good with point gradient formula. That's when it's really easy to see your y-intercept. So this is my point, not my point gradient formula, y equals mx plus b format. Put x is 0. I get y is 0 plus 1 on e plus e. So the y-intercept is just 1 on e plus e. Now I'm going to do a sketch, because these numbers just look a bit, you know what. But, so there is my x-intercept. There is my y-intercept. So this is the x-intercept. This is the y-intercept. All right. You know that e is approximately 3-ish. You can work it out if you want. -1 minus, that's about 8. It's about -9. It's down here somewhere. Okay. Whoa, whoa, whoa. Wrong axis. Wrong axis. X-intercept is about -9-ish. -1, you don't write -9, you go -1 minus e squared. And the y-intercept is about 2.7-ish plus a third. It's about 3-ish. It'll look like about that. 1 on e plus e. You can actually work it out if you want. So these are your x and your y-intercepts. They want you to find the area of the triangle. How do you find the area of that triangle? Come on, you can do it. No, don't need Pythag. How do you find the area of a triangle? That's the one. That's a right angle. What is this length? Oh, you're not going to like that. Well, it's not. Lengths are negative, never, ever negative. So the area is half the base times the height. Let's say that was -2 or something. You go, that is the same as -1 plus e squared. I've got to take the negative out. That point is -1 minus e squared. But I need to take the negative out, because you know you'd normally write -2, -3, -4. We know it's about -9. You know how we said it's about -9? It's the negative. I need to take the negative out and put a bracket here just in this case. It's -1 plus e squared when I factorize out the negative. Because the 1 plus e squared, yes, it's distance from the origin. So you've got to say it's negative this value. So this distance is 1 on e plus e. This distance. 1 on e plus e, that distance. No, yes. So it's a half of that. Now, the distance you use for b is not the negative one. Distances are not negative. A half bracket 1 plus e squared times 1 over e plus e. Now, you might want to write this as a common denominator. If you want, you don't have to. What are you going to do now with your brackets, you reckon? Expand? Expand the brackets. 1 times 1 on e is 1 on e plus e. What do you get here? E squared on e. So 1 times 1 on e is 1 on e. 1 times e is e. E squared times 1 on e is e squared on e, which is just e. Yes? No? E squared, look, e squared times 1 on e. Numerator is e squared. Denominator is e. And the last one, e squared times e is what? E squared times e is e squared times e to the 1, e cubed. Which is, oh, this is a nice one, isn't it? E plus e is 2e plus, no, all good, no. So it's a half, 1 over e plus 2e plus e cubed. You can't combine those. And that's what the area is. You can multiply through by 2 if you want, but you don't have to. That's it. You cannot combine a 1 on e with an e. It's like saying combining an x with a 1 on x. You can't. Mixed numeral improper fraction. No, you just got to be very careful. Don't play around with it. It's just too hard. If it was just an ordinary e, I'd say yeah, but just leave it. All right. Question 10 says, find the gradient and angle of inclination correct to the nearest minute of the tangent to that curve at the points where x is 0, x is 1, x is -2, and so on. We'll just do one of them or two of them just to get the method. What do you think? No. What do you think I should do? Well, we've got this. They're talking about the gradient. Differentiate, fantastic, which is the same. And then we want the gradient. Let's just do B and C. We're going to do B. So when x is 1, so they want you to find the gradient when x is 1 and the angle of inclination when x is 1. So when x is 1, the gradient is what? E to the 1, which is E. Now, what are they going on about this angle of inclination business? M equals tan theta. There you go. So they want you to use, so that's your gradient at x is 1. That's done. So the gradient at x equals 1 is E. Remember, E is just a number. It's almost 3. The gradient, it's almost 3. So now for the angle of inclination, we use M is tan theta, where M is the gradient. So E equals tan theta. This is just like solving tan theta equals 2.7. Just think of E as 2.7. So how do you do it? Theta is tan to the -1 of E. Off you go on your calculator. What do you get? 60? 9 degrees. Yep. Yep. Now, if you do tan to the -1 of 3, I think that's about 63 degrees, 26 minutes. So it's close. All right? I'm not saying to do 3, but you could check it. All right? So it's 69 degrees, 48 minutes. And when you want the gradient at, say, x is 2, you know what to do? We can do that. You just substitute x is 2. Same method, okay? So that was B. When you do C, when x is, -2, you get that the gradient is e to the -2, which is 1 over e squared. It's pretty flat. So girls, that makes sense, because if you look at the graph of y equals e to the x, it looks like this. And when x is 1 up here, when x is 1 on that curve, look, the gradient's like this, whatever. And they're saying this angle is 63 degrees. That's what they're saying, angle of inclination. But when x is -2, so that's when x is 1, for example. That's the tangent. The angle is 63 degrees. When x is -2, that is over here on the curve. Now this is a very flat gradient. The angle's going to be a lot smaller. So if I know the gradient, I just make it a tangent. The gradient's going to be a lot smaller. Well, it is. It's 1 on 8 or something, 1/8. So now m is tan theta for this one. I get that 1 on e squared is tan theta. Theta is tan to the -1 of 1 on e squared, which is, what, 10 degrees? 7 degrees, 42 minutes. Do you get the idea?